Okay, so probability distribution. First of all, you see our situation here. So you can see boy, boy, and boy. So what happened here is you are choosing either boy or girl actually. Okay, so imagine something like this. Okay, let's see. The first sibling, the second, and the third. So I start with a tree diagram. So the first one can be a boy or a girl. A boy, a girl, boy, girl, boy, girl, boy, girl, boy, girl, boy, and then girl. Okay, so that's why we have our result as in here. You can see 1 over BBB. BBB is this one. The first is boy, second boy, the third is also boy. So we end up with, okay, let's say I call it outcome here. So this is what we call boy, boy, and boy. Then the second one, as you can see this, what happened is in the second outcome is boy, boy, followed by girl. So we call this boy, 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 and girl. Okay, then the third one, we have boy, girl, and boy. Boy, girl, and boy. And the fourth one, we have boy, girl, and girl. Then followed by girl, boy, and boy. Followed by girl, boy, and girl. And followed by girl, girl, boy, and finally girl, girl, and girl. So we have all kind of situation. So that's why you have this situation. That's why you have this list here. And of course, in general, to get a boy, the probability is 1 over 2. To get a girl, 1 over 2. So what we need to do is we normally put the probability on the line in this particular way, on the line and below the line. So I put the probability there. And now, since we have 8 outcomes here, so each of them supposed to have their probabilities. So how to count the probabilities? For example, for the first way here is 1 over 2 times 1 over 2 times 1 over 2. So you will expect it is 1 over 8. And so the second one will be the probability 1 over 2 times 1 over 2 times 1 over 2, which is 1 over 8. So it seems like all the probability of these are 1 over 8. Okay, so I write down first the probability 1 over 8, 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 and 1 over 8. So we have 1 over 8 because it's 1 over 2 times 1 over 2 times 1 over 2. That's why we have 1 over 8 for all of them. And now, what we need to gather up in this table is what we call the number of boy in the 3 siblings. Number of boys. Okay, so let's say the first one, BBB. So for BBB, it is 3 boy. I name this column as X. X means the number of boy. So 2 boy. This one 2 boy. 1 boy. 2 boy. This is 1 boy. 1 boy and 0 boy. Okay, so now imagine that I start from the last one. No boy. Probability no boy, probability 1 over 8. So that's why 1 over 8 is there. Okay, 1 over 8. So this one we have done. Okay, I cut first. 1 over 8 has been considered. Okay, so this one settled already. Now the next one is 1. 1 means one boy in the 3 siblings. One boy. Okay, so we have this, and this. And you know each of this is having a probability of 1 over 8, 1 over 8, and 1 over 8. If you add them up, 3 over 8. So this one, and this one has been used. 3 over 8. 3 over 8. So it's basically this. Okay, I mark with a symbol. So it's this one, and this one. So 3 over 8. Now let's look at the next one. We have 2 boys. Okay, let's see the result. So we can take this, and this. Okay, so again the situation is 1 over 8 plus 1 over 8 plus 1 over 8, and that's why you have 3 over 8 as the probability. And the last one, 3 boys, the probability is 1 over 8. 1 over 8. So that's why we have this. So that is how we gather up. So gather up the 3 diagrams outcomes in a table. So this table, there is a special name. This table is called probability distribution. Probability distribution. Okay, so if you can put it in a more specific way, you see our topic here is probability distribution, which is the table that shows probability for different values of x. Okay, so we can make it more specific. We can call it discrete probability distribution. Why we can add discrete? Because, okay, I write down the reasons here. Discrete, because x is taking exact value. X is obtained through counting. Okay, so x is taking exact value. What is mean by that? So exact value, you know x is number of boy, so it can take 0 boy, 1 boy, 2 boy, 3 boy. That are the exact values. Not like decimal number. They don't take decimal number. They don't take x is 0.8 boy, so cannot be, you cannot cut the boy into 0.8, so we can't do that. So that's why x is taking exact value only, 0, 1, 2, 3, no decimal included. X is obtained through counting. You want to count, of course we have to count, right? Okay, how many boy? Okay, 1, 2, 3, we have to count like that, so it's through counting. So we call it discrete. So of course there is another one which is called continuous. Okay, they are like opposite to each other, something like that. Like if you have boy, then there is girl. So opposite. So if you have discrete, then there is another one which is not discrete. Not discrete, we call it continuous. So continuous is just opposite. Now I just tell you briefly first, because you will learn that also. Continuous is just the other way around, which is not discrete. For example, x can take any values in an interval. So can take a decimal number also, can take the integer, can take the decimal number. So x is obtained through measuring through measuring. So to make it clear, I give one example: height, weight. Give two examples. So these are continuous because first, height can be any value in a particular interval. Let's say height of human. So let's say it's like around 120 cm to 190 cm. Any value can be is possible. Include decimal. Maybe somebody is 165.3 cm. Okay, can take decimal. How you get the height? Measure. You need a measuring tape. How to get the weight? You need to measure by using a weighing machine. So we need to measure. Can take decimal. Okay, so that's why it's under continuous. Okay, now let's continue first. Discrete, which can take exact values only. So at the end, if you see this graph, you see the discrete is written here. Okay, so if you see this graph, right, you will have value at the integer values. I mean, you have probabilities at the integers value. Like for example, when x is 0, the probability is 1/8. So when you draw this graph, right, you have to label at the side here. Label this as 1/8. Okay, then after that, the next one, when x is 1, so the probability is 3/8. So 3/8, you have to label. You have to label here. Of course, this graph is a little bit inaccurate because you see the height is supposed to be triple of this one, but it seems like here it's just double of that, double of this one. So seems to be a little bit inaccurate. Supposed to be 3 times taller than the first one. Okay, so but it's still okay because after all this is just a sketching. So if it's inaccurate, you label at the side, then it is still acceptable. So you see 1/8, 3/8, 3/8, 1/8, which is from here. 1/8, 3/8, 3/8, and 1/8. And they put equal to 1 here because of one reason. You need to total up the probability. Total probability is equal to 1. So we need to know this as the important concept. Okay, because sometimes question may give you like they give you number, then unknown, and then number. So how to find the unknown? You add up everything equal to 1, and then you can find the unknown by solving the equation. Okay, so they may ask something like that sometimes. Okay, now let's see the question here. Part A. I think this is where there is a particular question. Find the probability that there are 2 boys in the 3 siblings. 2 boys. So we look at this, 3/8. Find the number of at most 2 boys. So at most 2 boys. So this one is 2 boys. This one is at most 2 boys. At most 2 boys means maximum 2 boys. So it can be 2 boys, 1 boy, 0 boys. Maximum 2 boys. So that's why they put px less than or equal to 2. Px less than or equal to 2, you can take 2, 1, and 0. You add up 1/3 plus 3/8 plus 3/8, then you get 7/8. Okay, so C, normally they ask this like this. They ask, find the probability that less than 2 boy in 3 siblings. Less than 2 boys. Less than 2 boys, you cannot take 2. You can only take 1 and 0. So that's why you take 1/8 plus 3/8. Then you get 4/8. Simplified it to 1/2. Part D, at least 1 boy. At least 1 boy. So this one, at least 1 boy, px more than or equal to 1. At least 1 boy is 3/8, 3/8, and 1/8. So that's how you get 7/8. So at least one boy, at least one boy. X can take 1, 2, and 3. So that's why 7 over 8. So of course, if you continue looking at this, right, there is an alternative way also. If you don't want to count directly, where you have to add up 1 boy, 2 boy, and 3 boys, there is another way, which is opposite way. We use this way when you have too many probability to add up. You see, you have 1, 2, 3, 3 values to add up. Actually, it's not a big deal. But if you don't want that, then you can just do in the opposite way. You take the total 1 minus with the probability which is not included. At least one boy does not include 0. So you take 1 minus probability of 0. Then 1 minus probability of 0, then you get 7 over 8, right? 7 over 8 is the probability of at least one boy. So you see, same answer. Count directly or use 1 minus the probability that is not included. Okay, now let's see. Okay, so this one is called conditional probability. Conditional probability. Conditional probability. Okay, so let's take a quick look first. What is conditional probability? Okay, I put it at the side here. Conditional probability. Basically, it sounds like this one. If event B has occurred, what is the probability of event A to occur? So then we write like this: probability of A given that B has occurred. So probability of A given that B has occurred, or if event B has occurred, what is the probability of A to occur? This is what we call conditional probability, where B is the condition. Condition means something already happened which may affect the probability of A. So this is the condition. So example is like, if it is raining, what is the probability that you go out to play football? So it seems to be like the raining is affecting, so which is kind of true, right? Raining does affect the probability of somebody to go and play football. Okay, so it should affect one. Okay, so if raining, what is the probability of you to go and play football? So something like that. Okay, so conditional probability. What is the formula for conditional probability? I write here. Conditional probability, the formula is, you take the two events and intersect, put them at numerator, then you put the condition, probability of the condition, at the denominator. So like that. Okay, so you just need to remember this formula, and then we should be able to answer the question already, or we should be able to look at the question and understand it already. Okay, let's see. Okay, let's come back to the question here. Part E. Px less than 2 given that x less than or equal to 2. So the question may sound like this. Okay, let's say I create the question. It may sound like this. Just now we already discussed less than 2 means less than 2 boys. Less than or equal to 2 means at most 2 boys. Okay, so Now, in order to put the question in words, I'm going to follow this way. If event B has occurred. Okay, so the question will be like this. Given that, sometimes they don't use if, sometimes they use given that. Given that at most 2 boys in the 3, given that there are at most 2 boys in the 3 siblings. Find the probability that there are less than 2 boys in the 3 siblings. So the question will sound like this, which looks like very complicated, right? Okay, so when you look at this complicated kind of question, right? So first you need to see keywords like, the keyword to use conditional probability is if and given that. Okay, so the keyword is there. Given that is written there at the beginning, and then whatever at the back of given that, at most 2 boys, that is the condition. So that's why conditions they put at the back. Less than or equal to 2. They put condition at the back, and then after they set up this condition, then they ask you to find the corresponding probability, which is probability that there are less than 2 boys in the 3 siblings. So the probability that you need to find, this one, is the front part. Okay, is the question, the condition at the back. In between, just put a line. Okay, so like that, and then after that, we supposed to use the formula, which is this formula. We're supposed to use this formula now. Okay, let's say you see if I use it. Okay, so I write here, easier to see, more contrast. Okay, so currently the question is px less than 2 given that x less than or equal to 2. Okay, now based on this formula, right? Okay, so I put the formula side by side, where you can see this is like A, this is like B. So we're supposed to intersect A and B. So that's why we have probability of x less than 2 intersect with x less than or equal to 2. Intersect. Divide by probability of B. Probability of x less than or equal to 2. So supposed to be like this, huh? Okay, so that's why you see here, we're supposed to start with intersection between x less than 2 and x less than or equal to 2. Okay, so at the end they simplified it to this, px less than 2. You see the numerator has been simplified to this. How they simplified it? Okay, you have to see the intersection. You may use number line to see that. Okay, or if I'm explaining this, I don't even need number line. I just list down, then you see the intersection. Okay, so something like this. You imagine our A, which is x less than 2, right, is 0, 1. Our B, which is x less than or equal to 2, right, which is 0, 1, 2. So A intersect B is basically the common one, 0 and 1, the common one between the two events. So because of that, 0, 1, 0, 1, 0, 1 is what? 0, 1 is x less than 2. So that's why when these two intersect, you just think of what exact value that can be taken, 0, 1, what exact value these can be taken, 0, 1, 2, and then when they intersect, you just think of the common values between these two sets. So the common value are 0 and 1. And 0 and 1 mean less than 2 no? So that's why the numerator have px less than 2 after they simplify. At the bottom, px less than or equal to 2 remain the same. This is the condition at the bottom. And now px less than 2, the answer is here, 1 over 2. So they put 1 over 2, of course they put 4 over 8 before simplifying. They put 4 over 8 on top. At the bottom they put the condition, which is px less than or equal to 2. From here, 7 over 8, they put at the bottom. Put 7 over 8. And then 4 over 8 divided by 7 over 8, then they get 4 over 7. So that's why we have this kind of numerator. So it is conditional probability. Okay. So we see f. F is again a conditional probability. So you see it's like px more than or equal to 1 condition. So this condition line, how it's supposed to look like? It's supposed to be vertical line. Supposed to be a vertical line, not like this. This is like delete. Delete in statistics means something else. Px less than or equal to 1, vertical line. Of course, the vertical line seems to be same with 1. So what we normally do, we make the vertical line longer than 1. Px more than or equal to 1, condition x less than or equal to 2. Okay, the question may sound like this. Okay, so may sound like this. You know, more than or equal to 1 is written here, at least one boy. At least one boy. Okay, x less than or equal to 2 is at most 2 boys. Okay, so the question may sound like this. Given that there are at most 2 boys in the 3 siblings, find the probability that there are at least 1 boys in the 3 siblings. So that may sound like this. So where we have to take it in this way. After the word given that or the word if, then that is the starting of the condition. At most 2 boys is the condition. Then they ask you to find the probability under this condition, which is at least 1 boy. So at least 1 boy is what they ask. And then at most 2 boy is the condition. So again, if this is the situation, let's say I write down again, px at least 1 boy, condition x at most 2 boy. So based on the formula that we have under conditional probability, so we're supposed to intersect them first. So you just see intersect 1, intersect with 2, divide by condition px less than or equal to 2. So supposed to be like this one. Okay, then after that, for the intersect, we just need to find out the integers, the exact values accepted by each of these. You know, this one, they can take 1, 2, 3. And this one, they can take 0, 1, 2. And then these two intersect. Intersect means find a common one. So let's see in between these two sets. The common one are 1, 2. Cannot take 0 because 0 is here but not here. Cannot take 3 because 3 is here but 3 is not here. We can only take the one that happens on both of the sets here. So 1 and 2 only. So end up with 1 and 2. End up with 1 and 2. And because of that, you see the numerator end up with px in between 1 and 2. The condition at the bottom remain the same, px less than or equal to 2. Okay, now px in between 1 and 2, right? How they get 6 over 8? So 6 over 8, you look at the table just now. Okay, the table which is up here. So which is the probability of 1 and the probability of 2. 3 over 8 plus 3 over 8, then you get 6 over 8. 6 over 8. Okay, so you get 6 over 8 up here. At the bottom, 7 over 8, which is px less than or equal to 2, which is our previous result under this at most 2 boys, 7 over 8. So they put 7 over 8 at the bottom, divide, then you get 6 over 7. Okay, so that is the first part. Okay, now the second part we have standard deviation. Standard deviation, the symbol is sigma. Sigma. So this symbol is called sigma. Sigma is a circle with a curly head. A circle, a 0, maybe you can call it 0 with a curly hair up there. So 0 with a curly hair, sigma. Okay, so sigma represents standard deviation. So sigma square represent variance. So we have standard deviation and variance. Okay, now let's see. Marks of students for mathematics. Okay, in a sudden they put this graph already. So just for your information, I want to compare first before we discuss with this. Okay, just now we talked about discrete and continuous. Discrete, right, the graph of probability versus x is normally like this, vertical line. But under continuous, the graph of there is a particular name for the fx, which is called probability density function. Probability density function. This one is just probability function. Probability function versus x, just now we learned already, which is this one. So a few vertical lines or a few vertical bar, it's up to you. But probability density function, you know, they can take any values in an interval. So we cannot expect to be like this anymore. No probability when x is 0.5 or 0.8, you know, no probability at this gap because they take exact values only. But continuous can take all kind of values, so the graph is just linked every way. So sometimes it look like a bell-shaped graph, sometimes it can be any curve lah. Okay, so curve of any shape in general. So bell-shaped graph is the most common one. So showing that there are values for all kind of, there are probabilities for all kind of x values. So that is continuous. So that's why when you see this graph, they are actually the starting of continuous already. Okay, they use a continuous graph to explain to you about standard deviation. Standard deviation is actually what? Standard deviation is how much it is the difference from mean. Okay, how much is the difference from mean? That is standard deviation. So of course there's a formula to count standard deviation. You want to find the difference from mean, there is a formula to count that. Okay, so the formula we don't care first. If later in this paper there is, then I just explain based on that lah. Okay, now let's understand it first. In this graph, right? In this graph, first we need to know how we draw the graph. It's like this one: fx versus x. So the question will tell you mean. Okay, will tell you the mean of your data. So let's say the mean is 68. So 68%, which is about the marks of students for mathematics. So in average, the students in the class score 68%. So that is the average or the mean. So mean 68%. 68%. So 68% will be the tallest of the mountain shape or the bell shape. Or in other words, we call this bell-shaped graph. Bell-shaped graph, the maximum happens at the mean. The mean is 68, then maximum is there. Okay, then how to relate with standard deviation? Okay, so I let you see one concept here. You take a look. Standard deviation and probability count. See the image. Okay, so we focus on, let's see which one. Okay, this one, the first one. Okay, you see this one. This one is good enough already. So mean is in the middle. If you move one standard deviation away from the mean, okay, so I labeled it so that you can understand more from this. Mean is here. So the mean, normally we use mu. This symbol is mu. Mu is u with one stroke in front. So mu. Okay, so if you are one standard deviation away from the mean, that is this one. This is mu plus sigma. Mean plus sigma is is one standard deviation from the mean. This one is mu minus sigma. Mu minus sigma. So these two values, they are a specific name. These two values is called one standard deviation from mean. So if you have to know that the probability for one standard deviation from mean is 68% probability. So this 68%, you don't misunderstand with the 68% that we talked about just now. The 68% is the average of the mathematic marks. So it's by chance taking the same percentage. It's just by chance only. Okay, you look at just now. Look at just now. 68% is the mean. Now by chance, one standard deviation from mean is also 0.68, 68% the probability. So it's by chance. It's not the same thing, Okay. Let's say I give another example. Let's say the mean is the height of the students. So the height of the student in average, their height is 158 cm, let's say lah. Now one standard deviation away, so let's say standard deviation is, we count already, let's say standard deviation we get 2. Standard deviation we get 2. Okay, so we get 2. One standard deviation away from the mean is 158 plus 2, which is 160. 158 minus 2, which is 156. Okay, so after that, the probability for the height to be one standard deviation away from mean is 0.68. Okay, so that is the first thing. If you are one standard deviation away from mean, the probability is always 0.68 for whatever continuous question. I mean for normal distribution. For normal distribution, okay, for normal distribution, one standard deviation from mean is always 0.68. Okay, then we continue our explanation here. If two standard deviation away is this one and this one. This is 2 standard deviation away. Okay, so which means what? Which means, let's say I use blue color now. 2 standard deviation away is mu plus 2 sigma, mu minus 2 sigma. So for example, for our case again, mean is 158, right? So 2 standard deviation away is 158. Wait, how come my words disappear already? Mu plus 2 sigma, mu minus 2 sigma. Oh, okay, still there. Okay, just now disappear in a sudden. Okay, mu plus 2 sigma is 158 plus 2 times 2. 2 times 2, 158 plus 2 times 2, that means 158 plus 4, 162. So this is 162. Okay, then this one, 158 minus 2 times 2, that means 158 minus 4, which is 154. Okay, so the probability for 2 standard deviation from mean, okay, I write in general first. in general it look like this one. In general it look like mu minus 2 sigma mu plus 2 sigma. In general, when it's 2 standard deviation from the mean, the probability is 0.96. It's already fixed. For normal distribution, 2 standard deviation from mean, the probability is 96% or 0.96. So 2 standard deviation for my example is 154 to 162. 2 standard deviation away, the probability is 0.96. Okay, so 3 standard deviation away, the probability is 99.7%. 4 standard deviation away, the probability is 100%. So these are the idea of standard deviation. Okay, standard deviation is normally the difference from mean. Okay, so that's the basic definition, difference from mean. Okay, now let's come back to this situation. They give marks of students for mathematics. So where in average 68%, and then let's say you have given with 70%, 50%, 50%. Okay. Here to here 2 only. Here to here 18. This should be very far. 50 should be further a bit. And then 40, then 20. You know, mean must stay at the maximum. And then 70 is just 2 units away from 68. 2 units away should be very close. This one, 68 to 50, should be 18 units away, so it should be very far. This one to 40 is like 28 units away. So it should be far, but this one should be close. Then 80, and then 100 let's say. Okay, so something like that is how is this related to standard deviation? Not related to standard deviation yet. We can't see the idea of standard deviation at all from this graph. We can't see anything yet. The idea of standard deviation is not applicable here. But but for the graph just now, you already know there is a relationship. Okay, if it's 1 standard deviation away from the mean, then how much probability it's covered? We already see that. But for this graph, we can't see any concept of standard deviation to be applied here yet. Okay, we look at the next page. Okay, now they give, if standard deviation is equal to 2, you see the mean is 68. Standard deviation is 2. Okay, so this is 1 standard deviation from the mean. You plus 2, you minus 2. That is 1 standard deviation away from the mean. Okay, let me label first. So this is mean plus sigma. This is mean minus sigma. Okay, so 68 plus 2 and 68 minus 2. So if you still remember the concept that we discussed just now, the shaded area here, okay, you have to understand this under continuous. Okay, so I put some comparison first. Discrete, right, and continuous. You learn these two together. I have to explain together. You have to see the difference. You see just now the discrete graph, it's like this. the continuous graph is like this. This one, the height of the vertical line or the vertical bar is representing probability. If you still remember what we learned just now, like what the 1 over a, the 3 over 8, so the height represents the probability. For continuous, right, where can we see the probability? So the area under graph represents probability. The area under graph represents probability. Okay, so that's why you see the notes that shade the region under the graph. The region under the graph represents probability. So that's why they shade that. Okay. If you still remember the value that I show you in the browser just now, I said 1 standard deviation away from the mean, the probability is 0.68. If you still remember that value, so I know this area, the shaded area there, the probability is 0.68. Okay, that means I can write something like this. 66 to 70, the probability is 0.68. And why 0.68? Because it is 1 standard deviation from the mean. 1 standard deviation from the mean is always 68%. Okay. Now this one, your standard deviation can be different value. For example, standard deviation is 18. If standard deviation is 18, right, in what situation it can be small, in what situation it can be big. I give you example. How come the standard deviation is 2, and in what situation the standard deviation can be 18? So example is like, let's say in this situation, which is about the marks of mathematics. If the students in the class most of them must score the marks which are very close to 68%. Let's say most of them score like 68, okay, 69, 67, and then 70, 60, 66, most of them score marks around here, and then the standard deviation will be very small. Standard deviation will be very big if the students' marks are spread far apart. Like some of them score 68, some of them score 86, some of them score 50 only, some of them score like 55, very far apart. The marks of the students widely spread, and then the standard deviation will be big. If the marks of the students are very close to each other, near to the mean, then the standard deviation will be very small. So let's come back to this. If the standard deviation is 18, right, so we just need to take the mean, the 68, plus 18 to get 86. Standard deviation minus 18, mean minus 18 to get 50. So if the standard deviation is 18, then always remember 1 standard deviation from mean, the probability is still 68%, 0.68. Okay, so variance. Okay, let's see variance. variance is sigma square. That means you take standard deviation, you square it, then you get variance. So standard deviation square. So that is the first thing that you need to know. It is standard deviation power 2. And then you get variance. Okay, now expectation of x, ex, equal to average values of x. Expectation of x is average values of x, which is the mean. Okay, which is the mean. Okay, so you see mean, sometimes we use mu, sometimes we use x bar. There are reason one, but for now let's don't care about that first. So whenever you heard expectations of x, what is that? That is mean. Okay, how to find mean? There is a formula. Okay, now they come back to discrete already. So you see a discrete, 0, 1, 2, 3, discrete. This is the same table with the scenario at the beginning. Number of boys in 3 siblings. The same table. Now they want to find the EX. The EX, why they use expectation? We can talk about it in this way. Expectation is used because how many boys do you expect to have? So how many boys do you expect to have? So that is the mean, and that's the mean, the average, the mean. Okay, what we expect is actually, you should expect the mean to happen. So the formula for expectations of x is summations of xi multiply with pxi. So why they put xi, pxi? It doesn't really matter one. You just need to know what to do. What to do is you have to take the first x value, multiply with the corresponding probability of x. So that's why when this is x0, then the probability must be the probability of x0. So like 0 times 1 over 8, this time this. Now when you change your x to x1, then the probability must be x1. Probability of x1, that means this x multiplied with this probability, as you can see here. Then when x is 2, x2, probability of x is x2. So 2 times 3 over 8. When x is 3, then the corresponding probability 1 over 8. So what we need to do is we take the x multiplied with the corresponding probability and add up the products. Then you get this. Then 12 over 8, right? So 1.5. 1.5. So you can see something like, you may think of, I thought discrete cannot take decimal. So how come this can take decimal? Mean can. Mean can take decimal, but x cannot take decimal. Mean okay. Okay, mean is okay to take decimal, but x cannot take decimal. Okay, mean, you see, is decimal here. So it's okay. So this is mean. Okay, so mean, remember the formula. Take the x, multiply the probability, and total up the products. Okay, now variance. Variance is another formula. You have to square. You have to square the x value, then you multiply with the probability. Okay, so for example, you see how I count the mean? I do it at the side here. I mean how to count the variance. Variance. Okay, based on the formula, you have to square the x, 0 square, time with the probability, 1 square, time with the probability, 2 square, 2 square, time with probability, 3 square, multiply with probability. This is the first part. This first part. Okay, second part, minus with ex power 2. Ex is the mean, 1.5 just now. Minus with 1.5 power 2. Okay, so that's why we need that table very much. That table will help us to find out all kind of probabilities question, then the mean, the variance. Okay, so all based on this table. So now let me count it. So I just count and find out the final answer for you. So at the end you get 0.75. 0.75, that's the variance. Okay, now let's see more information. Okay, so here we have ex equal to a. Example ex equal to a. If the mean is a, if the ex is equal to a, now if let's say it becomes e3x, so we just need to know when there is a number over there, how it affect the mean. So if there is a 3x there, then you can take out the 3, then it becomes 3ex. 3ex is 3a. So you substitute the a to the ex, so you get 3a. Okay, when we have 3 over there, then it becomes 3a. So example, let's say ex is, if you still remember our case just now, ex is the number of boy in the 3 siblings. So the number of boys, ex. Okay, so x is the number of boy in the 3 siblings. Then what is 3x? What is 3x? So 3x is just 3 times of the x. 3 times of the x. Okay, so let's say 3 times of the number of boys in the 3 siblings. It's just 3 times of that. Okay, just 3 times of the original statement. 3 times. Sometimes you heard 3 times, sometimes you heard triple. Okay, so when I say triple, then you should expect other terms like double, triple, quadruple, so 5 times and so on. So if you heard this kind of thing, then the x will change it to 3x, 2x when you heard double, quadruple, then 4x, 5x, 4 times, 5 times, 5 times. So when you heard these words, then you have to change the x to 3x. So when you change it to 3x, the average become from 1.5, right? 1.5 become 3 times 1.5, which is 4.5. Ex plus 2, if you plus 2, right? So what happens is you have to separate it to ex plus e2. Ex plus e2, ex remain as 1.5 for our example, will be 1.5. E2 will remain as 2. What happens to E2? You need to remember one concept. There is a concept which is like this one. When the expected value E take constant, we end up with a constant. Constant means no x. Okay, so you end up with constant. E2 you end up with 2. what kind of idea is that? E2 means your data is just 2, 2, 2, 2, 2, and so on. If your data are just 2, then in average, what are the average of all these 2's? So of course, you want to count the average of this, it's still 2. So if you have 4, 2, the average is add up the 2's and then divide by the number of data, 4. So you will still get 2. If you have 5, 2, so the average is still 2. So that's why E constant equal to constant. The average of data which is just A only, then the average is A. So that's why E2 equal to 2. So okay, now x plus 2. X plus 2, let's say for example, if x is the number of boys in the 3 siblings, so x plus 2 is what? So x plus 2, let's say the number of boys in the 3 siblings together with both of their parents, the father, mothers. So x plus 2 seems to be there. So the 2 represent the 2 parents. So then it will be 1.5 for the EX plus 2, 3.5. So 3.5 is the answer. Okay, now variant x, if let's say variant x is 5, example only lah, example, it's not based on this number of boys in the 3 siblings anymore where we get 0.75. Okay, so variant x is 5, then okay, so I don't want to link to the number of boys anymore because it is not that scenario already, because the variance for number of boys is 0.75. So let's say this is another question, or in general okay, in general, if variant of x is 5, so when the x become 2x, you will see in the question double of something or 2 times of something, so then what to do is these 2, right, have to take it out and square it. Why you have to square it? Because variance always involving square. You see the symbol of variance, already. Variance always involving square. So always involving square. So if you have 2 here, you have to square it first, then only multiply with the variance, which is 5. So have to square it. But if you have variant x plus or minus 4, we'll end up with variant x only. Where is the plus minus 4? Okay, so it's something like this one. You may be wondering, where is the plus minus 4 gone? So supposed to be like this. Variant x plus 4 is variant x plus variance 4. So I will tell you what happened to the variance 4 later. Variance x minus 4 is actually variant x plus negative 1 okay, I put like this first, step by step. Variance negative 1, variance x plus, we can take out the negative 1, negative 4, negative 4, variance 4. I take out the negative and then I need to square it. So based on this formula, whatever you factorize, you need to square it. I factorize negative 1, then I square it. you square the negative, then no more negative already lah. So that's why variance x plus 4, variance x minus 4 end up with variance x plus variance 4, variance x plus variance 4. So that's why they are same one. Variance x plus or minus 4 at the end, because you have to square the negative, so it will always end up with plus. And what happened to variance 4 seems to be disappear already. So in general, we need to know variance A is equal to 0. So for example, variance 4 is equal to 0. Why? Same reason like this. Variance 4, your data are just 4. Many 4. 4, 4, 4, 4. Your data are 4s. And what is variance? Variance, the concept is similar to standard deviation, right? Just that there is a square only. You know, standard deviation is the difference from mean. Variance is the difference and you square it, you know. So why 0? You see, if your data are just 4, are there any difference from each other? No difference from each other. There is no difference from each other. So that's why the difference is 0. 0 you square it is still 0, you know. So that's why I end up with 0. So standard deviation and variance is finding the difference between data. So no difference between them. That's why it's 0. So variance 4 end up with 0 because no difference between the same number or same data. So 0. So end up with variance x only. The variance 4 disappear already, becomes 0. Okay. Then cannot finish. Okay. Let's continue first. Standard deviation x 4.5. Sigma x. Sigma x 4.5. This is the symbol to represent the standard deviation. Sigma x. Sigma 2x. 2 times 4.5. You see the difference between variance and standard deviation. When you times 2 to the x, this one you need to square the 2. This one no need to square because standard deviation doesn't involve square one. So times 2, just times 2 only. This one times 2 square. So make sure you see the difference. Okay, so I just highlight this. This one you need to square. This one you don't square. You compare these two. Standard deviation of x is equal to a, let's say. An example no? If the standard deviation is a, what happens is standard deviation x plus minus b. Same with this one, plus minus 4. Then supposed to be something like this. Supposed to be standard deviation x plus or minus standard deviation of 4 or of b. So again, this is 0. This is 0. You know, imagine your data are just b, 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 b. Any difference between data? No difference because they are same data. So no difference between them. So the standard deviation are 0. Okay, 0. So end up with standard deviation of x. Standard deviation of x. Plus minus 0. So end up with just standard deviation of x only. So that's why you have this. Then standard deviation of x is a. Standard deviation of 2x, 2a. Standard deviation of 2x minus 3. So 2x minus 3. The 2 will make it to get 2a. The 2. get to A. The 3 here, which is based on this, the 3, standard deviation of 3 end up with 0. End up with 0. Okay, so remember the concept. Standard deviation of any constant is equal to 0. So because of that, standard deviation of 3 will end up with 0. Standard deviation of negative 3 is also end up with 0. So that's why this one will end up with 0. Only 2A. Okay, now binomial distribution. Okay, binomial distribution is applicable to the same scenario just now. You remember just now the number of boys in the 3 siblings, right? Okay, so you take a quick look on the tree diagram again. So it's boy, girl, boy, girl, boy, girl, boy, girl, boy, girl, boy, girl, boy, girl. Okay, so for these kind of tree diagrams, you can use binomial distribution to work out the probabilities and mean and variance. Okay, for this kind of tree diagram. What kind of tree diagram that I mean? It's a tree diagram with 2 outcomes, 2 opposite outcomes, boy and girl. Okay, boy and girl. So in general, they call it success failure. So let's say for example, our question is asking for the number of boys in the 3 siblings, right? So if you get boy, that means that is success. Success is something that fulfill the requirement of the question. That is success. Getting boy, success. Getting girl, failure. Success, failure, success, failure. It's based on the question one. Okay, so we have 2 outcomes. You see, every time when we consider boy or girl, there are 2 outcomes. So 2 outcomes is the first characteristics to be taken as binomial. Binomial, the word bi, right, means 2 outcomes. Then repeated n times. So how many times they repeat here? 3 times. First, second, third. Repeat 3 times. N equal to 3. Okay, so n equal to 3. So probability of success remain the same. You see, probability to get a boy is 1/2, 1/2, 1/2. Wherever you want to get the probability of boy, it's always 1/2. Okay, so we call it P, 1/2, which is written there at the side there. Probability of success, 1/2. And then you can use binomial. And then Q, probability of failure. That means probability of getting a girl, no? So probability of getting a girl is also 1/2. As you can see, wherever you consider your tree diagram, probability of girl is just 1/2 also, which is 1 minus P. So 1/2. So you have N, P, and Q. Each experiment is independent. is independent. That means this is the first time of doing the trial to check your the first I mean the first son or the first daughter is okay, to check whether they are boy or girl. So it's independent for the second one. The second one is son or daughter, and then the third one is son or daughter. So this is one experiment, this is second experiment, this is the third experiment. So they are independent from each other. That means they won't affect each other. The first one will not affect the second will not affect the third one. Okay, then in that case, if they fulfill 4 of these, then you can use binomial. You can use binomial. Okay, so I quickly tell you in what situation we cannot use binomial. If your tree diagram is like this, you cannot use binomial. Let's say about taking a driving test. Driving test is like this one. If you pass, then no need to take any more lah. You can drive already. You can drive for your whole life. But if you fail driving test, the first time you go for a driving test. So if you pass, you can drive forever already. If you fail, right, then you can try it again. Second time, maybe pass or maybe fail. So if you pass for the second time, then you can drive forever. No need to take the test anymore. But if you fail, then you take again. Pass, fail for the third time, and so on. So for this case, you cannot use binomial. Cannot use binomial. You see the tree diagram not balanced one, you see. They extend down here only. Here end of story, no need extend anymore. So cannot use binomial. Binomial is applicable if it is extended every way one. Okay, cannot be like pass cannot extend already, then cannot use binomial. So somehow the probability for each time for you to pass is different one, so maybe the first time you fail because no experience, second time maybe more experience already, the probability of pass is changing to different value. So the P is different every experiment, so cannot. P must be the same one, P must be the same. So every time same, then you can use binomial. So cannot use binomial because tree diagram is not balanced, because P is not a constant. Although it seems to have 2 outcomes every time, but still cannot use because of it breaks other rules. It breaks other conditions. So if you have fixed N, P, and Q, then you can use these to NCR, PR, Q, N minus R to find the probability. NCR, PR, Q, N minus R. How to find probability? Let's say example. I want to find the probability of no boy. You already know probability of no boy is girl, which is 1/8. Just now, if you still remember the outcome, 1/8. So Px equal to 0 means no boy. So we use formula 3C 0, 1/2 power 0, 1/2 power 3 minus 0. So 3C0, press calculator this is 1. Half power 0 is 1. This one 1/2 power 3, which is 1/8. So you can use this formula. Of course, if it is binomial, you better use this formula. Don't care about the tree diagram way anymore. So use formula to find px equal to 0, px equal to 1, px equal to 2, and px equal to 3. So, okay, px equal to 1, px equal to 2, px equal to 3. Can we find px equal to 4 or not? Cannot already lah, because maximum 3 only. If n equal to 3, you can find 0 to 3. If n equal to 4, then you can find probability from 0 to 4. Cannot use it to find 5, so the n will tell you maximum what value for your probability. Until 3 only for this case. Okay, then this one is about how to press calculator. This one we discuss later. Okay, we discuss this later.